Hello, my name is Alex, and today we will be deriving the simple torsion equation. So, if we look at the diagram here, this is the cylinder that is experiencing a torsion force. And if we look at the top of the cylinder, we see it as a radius r naught and an angled change of alpha. So, in order to derive this equation, we'll start with the equation for the moment. So the moment is equal to r times f times sine of theta. So theta being the angle between the force and the radius vectors. So as we can see here, the force is always perpendicular. Therefore, the sine of pi over 2 is equal to 1. So the moment is just r times f, or in this case, r naught. So we can take the derivative of both sides in order to get to dm is equal to r naught df, and we can also substitute in for df using the equation for torsion. So tau is equal to F over A, the force over the area, and if we isolate F to get tau times A and take the derivative on both sides, we end up with dF is equal to tau dA, and we plug that in for dF. After we do this, we use a little trick here. We multiply it by r naught over r naught, which is just equal to 1. And we actually combine these r naughts together to make r naught squared dA, and leave the tau over r naught outside. And this is important because when we integrate both sides, tau and r naughts, all the r naughts are in this case constants, so they will come out of the integral. But if we just take these two out, and we're going to be left with this integral here, integral r naught squared dA, and this is actually defined as the polar moment j. So plugging that in for j, we get m is equal to tau over r naught times j, and if we isolate tau in this equation, we end up with the m times r naught over j. So using this, we can go back to one of the other equations we started with. Tau is equal to g times gamma, and actually we can make them equal each other because they are both equal to tau, as we can see here. So g, which is the torsion modulus, times gamma, which is defined as r times d alpha dx. So d alpha in our case would be alpha itself, and dx would just be L naught, which is the length of the cylinder. So r is just r naught times alpha over L naught. So gamma is equal to r naught times alpha over L naught. And once we got gamma good, we bring this equation all the way down here, and then we see that the r naughts cancel out, and if we isolate alpha, we will get our equation. Alpha is equal to the moment times the initial length divided by the torsion modulus times the polar moment. And in order to get the equation that we saw in class, you would have to plug in the polar moment for, in this case, a cylinder, which is pi over 2 times r to the fourth. And plugging that into the equation, we can see we get 2m times L naught divided by pi times g times r naught to the fourth.